presentation, which will be done by a French representative, Beatriz B.Marcotegui, I hope my pronunciation is correct, who will tell us about TerraMobilita urban scene analysis.
Is the presentation?
Just wait a minute.
Thank you. So I'm going to talk right now about an ongoing research project, which name is TerraMobilita, which is focused on 3D cartography in order to, well, we'll see the services that we are trying to develop right after that. So I will focus in a small part of this project with a number of partners that are cited here. So I'm presenting my own work, but also the work of other colleagues. And each time I will provide with particular references, and we can discuss afterwards if you want to get in contact with those people. So the outline of the presentation is the following one. I will quickly introduce the TerraMobilita project and the particular aims, and then focus on acquisition and registration topics, and go through the urban scene analysis that I'm talking about, and conclusion and perspectives. So first of all, just a quick word about how I get this, how I discovered this conference. So I discovered your announcement in the ISPRS website. And it happens that I work in Fontainebleau, so I was quite surprised about that. And also I thank you for your kind invitation. It's my first Recurse conference, and I really appreciate it. So this is the building that is about 100 meters from the Fontainebleau Castle. And I belong to a center which name is Center for Mathematical Morphology, which was created 40 years ago. And just to say that it's a general image processing laboratory from the Paris School of Mines, dealing with any kind of images, either medical, seismic cubes, or multimedia images, trying to look for text in scene images. But I have no time to develop that, and I will focus on point cloud analysis. This is the focus of this conference. So get to the TerraMobilita project. The aim is to develop new automatic 3D approaches for urban modeling approaches, with the aim of reducing cost and delays of updating and creating new maps and new city maps. So we heard this morning that there are maps that are acquired 20 years ago. So our aim is to do it in a quite short time, even monthly. And we want to extract from the 3D information some other useful hints, such as the slope or the kind of surface road that you are going through. And also to be able to extract 3D information. For example, if you want to develop itineraries for soft mobility persons, for example, a person in a wheelchair, you need to be able to estimate which is the path width in order to see if you are able to pass with a wheelchair. Or if you are with rollers, you want to know if in your path there is paving stones, which is quite annoying if you want to pass through with your rollers. So this is the kind of problems that we are dealing with. So in the whole organization of the project, we will focus, as I said, in acquisition and registration and automatic 3D modeling. Let's go through acquisition and registration. So we already have data from different systems. So 2 mobile mapping systems that belong to the ParisTech, Lara 3D, and from IGN, so the Geographic French institution. But also with fixed scanners from Trimble company. They are working on other platforms that are a compromise between productivity and also accuracy. So we are going to see that we want to analyze accessibility in a city. So we want to analyze the curves and height of those curves. And if you go through a car on the road, go through Paris, and you will see that there are many parked cars that avoids you to see what happens behind. So they are developing a system in which is a stop and go. So it's something that all the device is embedded in a trolley that you push, and they are able to have much more. So they can pass through a small sidewalks and having much more precise details. So here are some examples of the stop-and-go acquisition system. And you can see that they are able to have consistent results in a quite large areas, as you can see here. And another example here in a very large scale, you can see that the acquisition system is able to register a very individual acquisition step. They are also focusing on developing a relative localization system in which they want to, based on the urban furniture, be able to register one station through the other. And they do it through range images, which allows them to develop real-time localization systems. So here is an image of the prototype. And also automatic targetless 3D scan registration with images in which there are planes, which is the case in urban scenes. So from different scans, from scan 0 to N, they detect planes and then they register those planes. And here are some examples in which you can see that from 230 stations, they are able to produce a consistent 3D model in only 3 hours with a very good average accuracy. And also another example on urban area in which with 1 billion points they are able to produce a result in 9 hours, which is quite a good result in that context. There's also a team working on accuracy assessment using extracted lines. So how can you be able to analyze if your system is accurate enough or not? And they developed a system in which it's a fully automatic analysis, and it's applicable also to heterogeneous data. You have references there, so I have no time to develop here. And there is also a system in which they produce data fusion with an IMU on one side and range images on the other side in order to get more precise localization system. And if you say more precise localization of the band, you also have more precise in your acquired data. So about 3D modeling, I will talk about automatic object segmentation. So the aim is not to have a point cloud in which you do not have any idea of what a pixel, of what a point is, but you want to say, okay, this point belongs to the facade or to the ground or to a car, pedestrian, whatever. So you are able to extract semantic information from the point cloud so that you can develop different applications. So, for example, if you are acquiring an urban scene in a street and you have a pedestrian, you should not introduce it in the map because it's not an obstacle. So you need to recognize what is in the scene so that you can produce automatically urban maps. So here's an example of this kind of approaches. So we also work on range images. And in the bottom of this picture, you can see that you are able to segment 3D point clouds. And then from this segmentation result, what we do is we extract features and we classify those objects that we segment. And we are able to say, okay, this is a car, pedestrian, or ground, like that. We have good results in our own databases, but we have also compared in the state of the art, and we found a database named Ohio. And here you have, so I go quite fast about it, you have into brackets, I don't know if I have not the mouse, sorry.
There is a mouse.
Okay, thank you. So here are our results. So this is F-min, quite usual measure that we made for classification. So we are over 80% of good classification rates, which is over the other state-of-the-art paper that is cited here, and in a time that is 5 to 10 times faster than the state-of-the-art with better results. So we have quite good results on that aspect. And I have to say that the computing time that we need in order to compute this classification step is about the time of acquisition from the data. About accessibility diagnosis, the question is, there is a law that says that we need to have equal opportunities for all. So we want towards a just society in which cities are supposed to provide accessibility for anybody, even those that are in a wheelchair. And they have to they have several years in order to get the city adapted for those people. So city halls require automatic methods in which they are able to say, okay, here there is a way in which you cannot reach in a wheelchair. And so what we are doing now is we are detecting curves in an urban scene, and then once we have that, we estimate the height of this curve, and we are able to produce automatic diagnosis of accessibility. Again, we have results on our database, but also we compare with the state of the art. And we see as before, in between parentheses, there is the competitive result of the state of the art. And we can see that we have very few false alarms. So most of what we detect are really curves. And we have lower rates in the completeness measure. And why? It's just because of occluded parts behind parked cars. So this is the most critical point of our system. That's why there are other platforms that are under development. So here just an example of all the things we do on a given example. So we have in blue the facades, in green, in grey the ground, yellow there are objects, and in red there are accessible curves, and in green non-accessible ones. Well, the other way around. The red are non-accessible curves and green accessible ones. There is also IGN who, after detecting curves, they are modeling in a very precise way the road on one side and sidewalks on the other one. And they provide very precise modeling approaches, and they are dealing also with occluding areas. So they are propagating information from one profile to the other ones, trying to overcome the problem of occlusions. So you have here an example of that kind of results. So as a conclusion, I would say that from the acquisition and registration point of view, there are competitive, automatic, targetless registration approach that is fast and reliable in quite large examples. In the TerraMobilita project, there are innovative platforms under development, such as StopNGo and other mobile systems, improving the accuracy of localization thanks to urban furniture and range images. And there is also a line-based accuracy assessment that is able to analyze the results that we obtain. From the 3D object segmentation and classification step, we see that we have faster and better results than the state-of-the-art compared with other public databases. I forget to say that we want to make available the databases we have from Paris to the community so that it becomes possible to compare results of different approaches. And finally, there is also road and sidewalk modeling in a very precise way, handling occlusions and obstacles. So, thank you for your attention, and if you have any questions.
Thank you very much. Questions, please. Пожалуйста, вопросы. Если вопросов нет, большое спасибо, и мы переходим.